Okay, this video is a continuation of section 2.7. I wanted to clarify some things from this morning about graphing and shifts and what all that means, to kind of help you guys a little bit. And you'll notice up here on the screen I have a graph of the parent function, y equals the absolute value of x. Now the parent function, again, as I go through and explain, this is the most basic absolute value, easiest absolute value one to graph. And you'll notice I have a t-chart over here to the left. These are the numbers that I put in. Okay, you can do it that way. You can put in numbers, -2 to +2, but it's not always going to match up with your graph, and that's why I do it with a vertex and those sort of things. But this is the most basic parent function, okay, of an absolute value, the easiest one you're going to do. And over here, you'll notice again over here to the right, the vertex in this case is the ordered pair 0, 0. There's no h, there's no k. The slope in this case, or the a value, is going to be +1. So from one point to the next, you're going to go up 1, right 1. Okay. Now, to kind of clarify from this morning how you shift and what those all mean, okay, you're going to shift from the parent function. So you have to think, okay, originally from the parent function, if I put a new graph on here, how is it different from the parent function? What did it do? Did it move right? Did it move left? Did it move up? Did it move down? Did it flip? Did it reflect? That's what flipping means. Did it flip? Is it facing down now? Did it stretch or compress? Okay, and I want to talk about those, and I'll show you. I showed you a little bit of description on stretch and compress this morning towards the end of class, but I want to show you the difference between the two graphs. Okay, so this is the parent function. Now, what I've done here is I've given you, there's two graphs I want to look at, and I'll show you how we describe those transformations and how it actually happens. Okay. All right, now you'll notice here on this next example, I have the parent function. It's got a letter P on it. This is the parent function right here of y equals the absolute value of x, and I've labeled it right here. Okay. Again, I've given you an equation. Here's your equation, y equals the absolute value of x minus 4 plus 3. Okay, so if I were to graph this, this would have a vertex of the ordered pair 4, 3. The slope, or a, is 1. Okay, so I would go right to the ordered pair, right 4, and I'd go up 3, that'd be my vertex. From there, I'd go up 1, right 1 to put a dot, and up 1, right 1 to put a dot. Okay. The axis of symmetry is x equals 4, or the x equals the x value of the vertex, and then I could reflect it across 1 unit over there and 2 units over, and now I have my graph. Now, describing the transformation. Okay, what happened to it? How did it change from this first original parent function? Okay, and I told you this morning that you're looking at the vertex at the first part. Okay, again, this number here tells you how much it moves right or left. This number here tells you how much it moves up or down. Okay, the slope, or a, tells you whether it stretches or compresses. If it's bigger than 1, it stretches. If it's less than 1, it compresses. If it's between 0 and 1, it compresses. Okay, if it's 1, it didn't stretch or compress. It stayed the same. Okay, so as I look at this graph, to shift from here to there, what happened? Okay, how did we shift it? All right, so as I look at this now, to get from this parent function, from A to F, here's what they did. On the shift, it shifted right 4, which is this number right here, right 4, and it shifted up 3, which it comes from this number right here. Okay, and it didn't stretch or compress, and that was it. You'll notice to go from A to B, I got to go up 1, right 1. That's the parent function, right? To go from F to G, I go up 1, right 1. The slope didn't change, so it didn't stretch or compress. And that's your shift, right 4, up 3. So essentially, I just took this parent function, I picked it up, I moved it right 4 and up 3 each point, and now I have the exact same graph except for it's in a different location. Okay. All right, now one example here quickly, and you'll notice this one's a little bit different. Again, I have the parent function here. This guy right here is the parent function. Y equals the absolute value of x. And then I have another equation, y equals -2 times the absolute value of x minus 2 plus 5. Okay, so let's talk about this equation right here. Okay, let's take the vertex is at the ordered pair 2, 5. Let's see here, a, or the slope is -2 or -2/1. Okay, and because a is bigger than 1, it's 2. Remember, it's the absolute value of a tells us stretch or compress. And the absolute value of -2 is +2, so that's bigger than 1. So this is going to stretch. And when I stretch it, we said this morning, if we stretch it, it's going to narrow it out a little bit. Okay? So what is our transformation? All right? How do I get from this parent function, v that looks normal, to this guy right here? Okay, well, let's first talk about the movements. How did the vertex move? Well, the vertex moved, this vertex here went from 0 to 0, 0, 0 to these two digits. So the vertex moved right 2, and it went up 5. Here was your original vertex. We went right 2, we went up 5, there's your new vertex. Okay. Now, you'll notice that the a value here is negative. So we have a slope of -2, down 2, and right 1, which that means we also reflected it. That's the same thing as flip. Flipped it the other direction. Now it's facing downward. Okay. And then finally, we stretched it by 2, whatever that a value is, the positive a value is here. We stretched it by 2, which if you look at the original parent function here, it is wider. Okay, and you'll notice the difference between size-wise between the parent function. It's way wider than the new function you've created. It's a little bit narrower, and that's because of this stretch right here of 2. Okay, so hopefully this will help you understand what we're trying to describe when it comes to transformations and movements and shifts. Okay, we're starting with the parent function. How do we end up with the equation that we have? That's how you describe the shift. Okay, all right, this is the last part of section 2.7, and this is describing transformation shifts.